and welcome back to Scale Me Down and to part 2 in this series where we build, review and convert this Hangar 9 Pawnee Brave into a towplane. Remember to like and subscribe to support the channel. In the last episode we assembled the model and modified it to fit the multiplex tow release. And since then, off camera, I've tidied up the radio gear installation, balanced and fitted a propeller, and cut some custom vinyl registration stickers. First, let's set the centre of gravity by positioning the flight battery. Our 10S pack is fastened onto the supplied sled, which has this protruding bolt which locks into a slot in the fuselage. The whole assembly is then secured by a nylon thumb screw. You only get one sled supplied, and weirdly they're not available as a spare part, so I drew and laser cut my own for some additional battery packs. So let's connect the batteries up and see how much power we get. The pack is made up of a 6-cell and a 4-cell battery that are connected in series to give 10S 5000 mAh. I tried a few propellers around the suggested setup and found that a 20 by 10 wooden propeller provided the closest power to our target of 2.2 kilowatts. However, due to ground clearance, I'm going to conduct the maiden flight on the 1810 propeller. I conducted a range check and then launched into this rather blustery day for her maiden flight. I first trimmed out the elevator, ailerons and rudder. I checked the centre of gravity, which I moved back quite a bit from the stock position, and checked the flap to elevator compensation, which only needs to be minimal. Now let's see how the additional weight of this setup has affected the handling. The stall took some provoking and it gave plenty of warning, but if I persisted she would spin. Recovery is easy and there's plenty of authority even on low rates. And low rates were fine for the whole flight. The flaps are fairly powerful and they make landing easy. Over the next few flights, I'll tune up the AS3X system and I'll change the prop. There's already plenty of power, and after 6 minutes of flight, there's 50% remaining in the battery. The extra power will be useful for towing the bigger gliders. You saw from our testing that this 2010 propeller provides the best power for this setup, but I have a problem with ground clearance. To compromise, I'm going to use a 19 by 10 3-blade propeller. It's just that I can't quite get one commercially. So I'm going to make one from these 2-bladed wooden 1810 propellers. To keep the drilling accurate, I've drawn and 3D printed these templates, these guides. So let me show you how they work. This first guide for drilling the propeller securely fits to the hub. I use it in combination with the pillar drill to accurately place the holes. Then I cut the propellers in half using the bandsaw. I make the hub plates using 2.5mm epoxy board from McGregor. After drilling the 12mm hole for the propeller driver, This 3D printed guide clips into place to once again accurately align the holes. I prepared enough blades to make 2 propellers with some spares, so I weighed each blade to find the most closely matched sets. I fastened each blade between the 2 hub plates with 2 M3 bolts and flanged nylock nuts, before balancing the whole assembly. Now, let's put it back on the aeroplane, connect up through the watt meter and test it. There we go, perfect. That gives a power of about 2,300 watts, which of course should unload a little bit down below 2,200, which is what we're looking for. To make the spinner, like we've done before here on the channel, I made a mould in 3 parts on the 3D printer that I laid up with fiberglass cloth and epoxy resin. After a bit of trimming, I secured it to the back plate with these 3D printed fittings that I designed to hold captive M2 nuts. But how does it perform on the plane? Well, an instant improvement, particularly to the climb rate. And there's a bit more drag from the propeller whilst throttled back, as you'd expect. And whilst I was at it, I also moved the centre of gravity slightly, which has further tamed the stall, along with tuning the AS3X settings. I think this new propeller sounds lovely, and performance is now truly vertical. Looking at the pack after this flight, this 10-cell setup should provide 6 minutes of full throttle towing without anything getting particularly hot. I think we're finally ready to tow a glider. And for this, we're going to use our Condor Evo from Fly Models. This is a 3-meter span glider, and it weighs 3.06 kilograms, or around 6.5 pounds. Connecting the two is 50 feet of Kevlar twine with monofilament fishing line weak links and swivels. It was clear we had a winning combination here, with the glider pilot ready to release in just a few seconds. And once we had both seen that the glider had released cleanly, it was time for me to dive off the height and land in readiness for the next tow. Once again, listen to that lovely roaring sound from the propeller. There were some isolated pockets of thermal lift here and there, but on this particular launch we didn't have to wait long to witness the glider execute a graceful landing under full crow braking. Then, as if to show us how it should be done, this little guy showed up, so we connected up and launched again. The glider pilot got many long flights on this day, and we both had lots of fun. I find the team element of aerotowing adds a whole new dimension to the hobby and is a great club activity. As for this Pawnee Brave, you can expect the usual high quality product from Hangar9. I found one or two issues, but they were easily resolved. And despite the increased weight of my power setup of motor, battery, ESC and prop, it should easily have enough urge to pull up to 4 meter gliders, and due to the wide speed range should be suited to both vintage or modern composite types. Flight handling is very benign and I find it lovely to fly and great fun. Hopefully it should provide many glider launches and lots of fun in the upcoming seasons. Thanks for watching, and we'll see you here again at Scale Me Down.
Handbrake turn, like it.